In this video, we are still on lesson 4. We're looking at composition of functions, but this is kind of a continuation of the original first video. We did some examples, right, where we just did basic substitution type problems, but now I want to look at f of g of x and g of f of x types problems. All right, and it's not always those variables, all right, but that's just kind of the most common that we use. All right, so with these are called composition of functions. You may see it or hear it called FOG and GOF because f of g of x, g of f of x, okay, FOG and GOF. All right, but what ultimately this means is that you're taking one of these functions and you're substituting it into the other function. So when you see f of g of x, well, what is g of x? This is like saying f of x plus 5. Because we know what g of x is. So now that it's written this way, we take the x plus 5 and we're substituting it into the f function. So instead of saying 2x, we say 2 times x plus 5. The x plus 5 is replacing the x. So when we distribute that, we get 2x plus 10. So that is f of g of x. All right, now for the second example, we have g of f of x. Well, what is f of x? We know f of x is 2x. So again, we're substituting that into the what? The g function. All right, so this gets substituted into the g function. All right, so that's x plus 5. So instead of saying x plus 5, we have something plus 5. X plus 5 is something plus 5. 2x drops in, and 2x plus 5 doesn't combine, so it's just 2x plus 5. All right, so long story short, one function gets substituted into the other function and vice versa. The hardest part is making sure that you substitute the right one into the other. All right, sometimes those get mixed up. All right, so if you flip over on page 18, we have some more examples. Try to make it where you can see this a little bit better, but it's tough. All right, so f of g of x. Well, I know g of x is x minus 1. So I'm substituting that into this function. All right, so I'm going to have something squared plus 2. All right, something squared plus 2. I'm basically taking the x and I'm putting in a parentheses. All right, so x minus 1 is what drops. But now we have to square that. And this is probably one of the hardest problems on the page because when you have x minus 1 squared, remember it's x minus 1 times x minus 1 plus 2. So I'm going to have to distribute. I'm going to not put all the little rainbows because it's going to take up a lot of space. But if I distributed this, I would have x squared minus x plus 1, and I still have a plus 2. So when I combine my like terms, I get x squared minus 2x plus 3. That's a tough problem. All right. The next example is g of f of x. Well, what's f of x? It's x squared plus 2. But we're substituting it into the g function. So instead of saying x minus 1, I have parentheses minus 1. And then this just drops in. So I would drop the x squared plus 2 in and then combine my like terms. Well, here I'm not multiplying anything. I'm really just subtracting 1. So I can combine my like terms to get x squared plus 1. And that's it. So one more example. All right. With this one, we have f of g of x. Well, that g of x is 4x plus 9. And we need to substitute into the f function. Well, the f function is 3x, so we're going to have 3 times something. So remember, I'm just changing the x to a big parenthesis. Well, what goes in the parenthesis? 4x plus 9. And then we distribute to get 12x plus 27. Last one, g of f of x. Well, we know that f of x is 3x. So we're substituting into the g function. So instead of saying 4x plus 9, we're going to say 4 parentheses plus 9. So again, instead of saying 4x, I have 4 parentheses. I still have the plus 9, so be careful. Sometimes people forget and they drop it. All right, so what goes in the parentheses? Well, the 3x. Distribute to get 12x plus 9. Nothing can combine, so 12x plus 9 is your solution. All right, so that is composition of functions. So now you have several problems to try on your own. So go ahead and try those problems.